Alright, this is part 2 of our lesson on applications of quadratic functions. Alright, we're dealing with parabolas and we're looking at some real world problems. So let's check this one out. Alright, remember that these parabola problems often follow this pattern where something's going up and down. And as you read the problem, ask yourself, are they talking about position A, position B, or position C? Alright, if they're talking about position B, that's the vertex. We'll do opposite of B over 2A to find the x value, or it's usually time. And then we'll use the table feature to find the height or whatever that goes with it. If they're talking about the C value, then that just means that the height is 0. So basically we'll set the function equal to 0 and solve it, probably using the quadratic formula. Okay, so let's see what we're dealing with this time. So we have a water balloon being thrown upward from a height of 10 feet with this initial velocity, blah blah blah. It follows this model. T is time, h is height. Okay, what is the maximum height the balloon reaches? Now, if you just watched the previous video, I encourage you to pause the video and try to do this problem by yourself. If you didn't watch the previous video, you should go watch the previous video. Alright, either way, try to do this problem by yourself first. Alright, let's pretend that you did that. So, the maximum height. Which part of the path are we talking about when we talk about the maximum height? Okay, we're talking about position B, right? So that's the vertex. So basically we're finding the vertex then. So we're going to do opposite of B over 2A, and that'll give us the x value, which is actually time now. And then we'll find the height that goes with it. So let's do that. So remember, we're finding the vertex, so that's opposite of B over 2A will get us started. Okay, so let me zoom in a little bit. Okay, so we're looking for the maximum height, so that means we're looking for the vertex. Okay. Now remember, the vertex is going to be like time, comma, height. Okay, so the way that we will find the time is we will do opposite of B over 2A. Okay, that's how you find the x value of the vertex, which in this case is time. So opposite of B over 2A, so that's going to be negative 46, okay, opposite of B, over 2A. So that's 2 times negative 16. Okay, so that's negative 46 over negative 32. Or if need be, I could put this whole expression in the calculator. So negative 46 over 2 times negative 16. Okay, I'm getting 23 over 16. Okay, let's see what that is as a decimal. So if I want to turn that into a decimal, I'm going to hit this button right here, the toggle key. Okay, so that's turning this into a decimal for me. So it's 1.4375. Okay, so for right now, let's keep all of those wonderful decimals. Okay, so for right now we're getting that T is 1.4375. Okay, that's seconds. Alright, but they're not asking us for the time. They're asking us for the maximum height the balloon reaches. Okay, so we've got the time. Now we need to find the height that goes with it. So the way we'll find that is we will use the table feature of the calculator. Alright, so let's put this equation into the calculator. That was supposed to be a 16. I'll just retype it. Negative 16x squared plus 46x plus 10. Okay, so we've typed it in. Okay, let's tell it where to start. And again, we want it to start at the time we just found. Okay, 1.4375. Okay, so 1.4375. Okay, so the y value that goes with that is 43 point, and I'm going to go ahead and round to 2 decimal places, so 43.06. Alright, I don't like to round until the end. That's why I didn't round these decimals. I used all those good decimals so I could get as much accuracy as possible on the height, which is the thing that we really wanted. Okay, so the maximum height. Alright, so we just found the vertex, guys. So understand this. The vertex in the form of time comma height is this 1.43 seconds at 43.06 feet. Okay, so this is the vertex. So you know that it's at the very top of this path. So that means that 43.06 feet, that is the maximum height, and 1.43 seconds, that's how long it takes to get there for the balloon. Alright, but anyway, the answer to the question is, what's the maximum height? 43.06 feet. That's the answer. Okay, alright, what about part B? How long does it take the balloon to reach the ground? Okay, so how long does it take to reach the ground? Well, which part of this path are we talking about now? Alright, we're talking about C. We're talking about hitting the ground. Alright, so the only thing we know about point C is that the height here is 0, because this is where it hits the ground. Okay, so whenever you're dealing with that position, that means the height is 0. So we're just going to plug in 0 for the height. So let's just copy this down. Alright, so this is the function. I just copied it down. But if we're talking about the ball, or the balloon rather, reaching the ground, that means that the height is 0. So I'm just going to go ahead and plug in 0 for the height. Alright, and so this is what the equation becomes. And now that we have it set equal to 0, we can solve this using the quadratic formula. So of course the first thing we'll do is find the discriminant, which is b squared minus 4ac. So in this case, that'll be 46 squared minus 4 times negative 16 times 10. Alright, so here's what that would look like. Let's go ahead and find out what it is. Alright, that's a really big number. So the discriminant is 2,756. Okay, so now let's go ahead with the rest of the quadratic formula. So the rest of the quadratic formula goes, you know, opposite of b. So in this case, opposite of b And remember, we're finding, this finds us the x value, which in this case we're calling that those x's are t's instead. So t equals opposite of b, so that's negative 46 plus or minus the square root, and under the square root goes the discriminant, 2,756. All over 2a. Well, a is negative 16. So 2 times negative 16 is negative 32. Alright, so all we really have to do is simplify this. Let's see what the square root of 2,756 is. Okay, it's this whole decimal. So that doesn't really help us. So here's what I think we should do instead, since that's not, you know, a simplified radical or anything. Let's go ahead and put this entire thing into our calculator. Okay, we'll do it once for the positive version and once for the negative version. So I'm going to type it in with a plus, and I'm going to type it in with a minus, and I'm going to get these two values for time. Okay, so if I put this in, negative 46 plus square root, okay, here's what I'm talking about. So go into fraction mode right away. So we will type in negative 46 plus square root, and it was 2,756. Okay, so 2,756. Alright, over negative 32. So negative 32. Okay, that gives us negative 0.20. Alright, so that's negative 0.20. Whoa, it moved. Okay, it looks a little crazy. Alright, so that's one value of time. Alright, we'll talk more about that in a second. Alright, so we did the positive version. Now let's do the negative version. Now, here's one thing you can do. If you don't feel like typing the entire thing over again, you can use your up arrow key and get up to where this is highlighted and just hit enter. And it brings this expression back for editing. So you can just use your left arrow key and get over to this plus and turn it into a minus, and then just hit enter. Alright, just saves you a little bit of time. So now we're getting 3.0, and I'll call it 3.08. I'm going to round up because the next number is higher than 5, so 3.08. Okay. Alright, so these are the times that would give us a height of 0, alright? Because remember, we got this by setting it all equal to 0. But only one of these times makes any sense. Okay? Is it possible for the balloon to hit the ground 0.2 seconds before we threw it? No. You can't go back in time. We do not have a time machine. So this solution is extraneous, so just ignore that. Only use the positive one. Okay, so they must be talking about a time of 3.08 seconds. That's the time when the height was 0. That's the time when the balloon hits the ground. Okay, so that's the final answer. 3.08 seconds. Okay, what about part C? When will the ball reach a height of 35 feet? Okay, so 35 feet. Remember, all of our points are in the form time, comma, height. okay, because time is like our x values when you look at the formula, and height is like our y value, so time comma height. So by giving us a height of 35 feet, it's like they're giving us a y value, and they're asking us the x value that goes with it. But we can just use the well, can we use the calculator? Let's see. Alright, we still have the equation typed in. We may not be able to use the calculator. Let's see how close we can get. Alright. Alright, I'm just going to start off at time 0. Okay, so here's why the calculator is not helping us enough. Because this is going up by even seconds, and it goes from 40 feet to 38 feet. It skips right over 35 feet. So I need more accuracy than this. So here's what I'm going to do. They are giving us the height is 35. So let's just plug in a height of 35. Okay, and we'll have to do the quadratic formula again. So basically last time when we were talking about hitting the ground, the height was 0, so we plugged in 0. This time, instead of plugging in 0, we're going to put a 35 right here. Alright, in for height. Okay, so let me just move some of this out of the way. Alright, so I just copied down the formula that they gave us in the beginning of the problem. Here's the formula, but they're telling us that, okay, the height is 35 feet. So let's just substitute 35 in for the height. So if I do that, if I substitute 35 for the height, then what I have is 35 equals negative 16t squared plus 46t plus 10. Okay, so I just need to solve this for t. Alright, because they're saying when. Alright, the word when is asking us for time. That's t. Okay, so let's go ahead and subtract 35 from both sides. So that's going to give us 0 equals negative 16t squared plus 46t minus 25. Now that we have 0 on one side, we can use the quadratic formula. Alright, the first step of using the quadratic formula is to find the discriminant. B squared minus 4ac. Okay, so that's going to be 46 squared minus 4 times negative 16 times negative 25. Okay, so let's see what this gives us. Okay, I'm just typing it in. So then I've got negative 25. Okay, that gives me 516 for the discriminant. Alright, 516. That's your discriminant. Now that we have that, we can go ahead and do the rest of the quadratic formula. Okay, so normally we say x equals, but we're going to say t equals opposite of b. Okay, so that's negative 46 plus or minus the square root of 516 all over 2a. Okay, so that's all over, alright, 2 times negative 16 is negative 32. Alright, since we are doing a real world problem, decimals will be just fine. So I'm going to recommend we go ahead and put this entire thing into the calculator. Of course, you can't put plus or minus in the calculator. So we're going to put it in once with a plus and once in a minus and see what we get. Okay, so let's do it with a plus first. So negative 46. Okay, so go into fraction mode right away. So negative 46 plus square root of, what was it, 512 Yeah, 516. I'm glad I checked. Alright, and then it was over negative 32, right? Because that was 2 times negative 16. And let's just hit enter. Alright, it's giving us this expression, but we need the decimal for a word problem. So just hit your toggle key, this button right here. Okay, so that's giving us 0.73, I'm going to round, alright, 0.73 seconds. Okay, so 0.73 seconds. Okay, so that's one possibility. Now let's type it in again. Alright, we did the plus, this time we're going to do the minus version. Alright, and again what you can do is use your arrow key and go back, alright, to where you typed it in, and just hit enter. So we can just go back and change that plus to a minus, and that will save us from having to type it all over again. Alright, so I'm just changing that plus to a minus, and I'm hitting enter. Okay, again it's giving us this sort of simplified expression, but we don't care about that. We want the decimal. So 2.15 seconds. I'm rounding up. Okay, 2.15 seconds. Alright, so we're getting 2 different times that are possible. None of these are negative, so neither one of them are extraneous. So how is this possible? Okay, so just understand this, guys. They're asking us, when will the balloon reach a height of 35 feet? Well, I want you to understand that looking at this picture, maybe you can understand, imagine that we're talking about reaching a height of 35 feet. Okay, so let's say that this was a height of 35 feet right here. 35 feet. The balloon is going to reach a height of 35 feet twice. It's going to reach it once on the way up, and then it's going to reach it again on the way down. Okay, so that's why we're getting 2 different heights. So it's hitting it on the way up 0.73 seconds after it was thrown. Okay, so this is the time of 0.73 seconds, but then more time goes by, and then now it's coming down, and so the 2.15 seconds must be the time when it's on the way down. Alright, let me just move this out of the way so I can do this properly. So right here must be the time equals 2.15 seconds. Okay, so that's why we have 2 different times. Once on the way up, alright, the shorter time, and again on the way down, okay, a little bit longer time. Okay, and we'll go ahead and just keep both of these. Alright, let's stop the video there, because that was problem number 2, and this video is plenty long enough. I think we still have a couple more problems left. Oh, the rest of this is review. Okay, so I will make a video of the review part, but I'm going to put that in another video. I'll see you on the next video, guys.